of the Python Data Science Introduction course workshop. Today we're going to be talking a lot about pandas. All right, one more joining us. Has anyone here worked with pandas before? Feel free to put it in the chat or speak out loud. New to pandas? Yes, all right. Great. Cool, so I'm gonna start sharing my screen here and we can just walk through some of the opening parts of it. Basically, pandas is a cornerstone of the data science with Python ecosystem. It's built on top of NumPy, which we worked with in day one. And if you take a look, the reason that they call it pandas is it's derived from the term panel data from econometrics, and it just basically refers to data that includes observations over multiple time periods for the same individuals. In other words, we're working with data sets that are included in a sort of interactive object. And the primary object that we're going to be working with is a data frame. That's going to include a lot of the data that we're going to be working with. And it's, again, a really crucial part of the pandas library. So why don't we jump in here? I've got my Jupyter Lab going. Make sure that's running and that I didn't time out. So if you haven't opened up your notebook, of course, please do that. You should be seeing what I'm seeing here. If you've been joining us for the last couple sessions, you'll know that there is one notebook that is the complete with all the answers. And then there's also one without the complete. And that is going to be the one that we're going to be following today. What's great about pandas is that it's powerful, it's dynamic, and it is a massive library. So we're going to go through a lot of how you might get started with pandas, and then we're going to sort of finish that up next week. But if you read through the documentation or do any YouTube tutorials, a lot of people in this world will say, don't try and memorize pandas, right? It's way too big to sort of wrap your arms around all at once. And so, you're going to be looking stuff up even, a couple years into using it. So the big idea is that you want to take away how to use it, how to think about it. And then that way, you can be efficient with it as you do continue to use the reference material down the road. So you'll also notice that we have a somewhat, it's a larger data folder here. We're going to be working with different data types. We're going to be working with Excel files. We're going to be working with CSV files. We're going to be working with JSON files, HTML, a couple different ways of approaching our data structures. And Pandas is great because it has a really robust IO or in and out functionality, input output functionality that makes it a lot easier for us to work with. So the first thing that we're going to be doing is we're going to be working with data frames, and we're going to be loading in just kind of a sample data set. And of course, as I continue to say, if there are any questions along the way, feel free to stop me, open up your mic, and we're a small group here, so we can have that be possible. Great. So what we're doing here is we're going to be importing pandas as PD. That's a kind of a standard thing, and we're going to be using a read CSV method, right? So of course, CSV is comma separated values. And if we look at the data that we've got here, this is a really simple Excel, basically an Excel spreadsheet, right? I'm using numbers here, so it might not look like Excel, but it's basically just comma separated values where you have a country and you have the unemployment rate, and together they comprise the unemployment rates for the year 2016 for what you might call Europe, which is somewhat fluid of a term. But I took these numbers offline, off the internet. I got it off the World Bank. And I just put this in here so that, we could work with it somewhat easily. But you can just see that, again, these are not very specific numbers. Some of them are just straight integers. Of course, if we wanted to actually do a report on unemployment in Europe for the year 2016 or any other year, we want to be more specific than this. But again, this is an introduction to how to work with this data structure, not necessarily how to be as specific as you might need be if you're going to be working in this space. So we're looking at that as a data structure. And what's really great is that we are able to just use a simple read CSV method and then store it in what we call a data frame. So we run that cell and we've now got all of that data read into our unemployment data frame. So let's take a look at what our type is for this. And if we just put in unemployment DF, of course, I'm using the built-in type function that comes with Python. And if we get that, we see that it's a data frame, right? We see that Python understands it's a data frame. Let's take a quick look at just what the documentation says about this. A data frame is a two-dimensional, size-mutable, potentially heterogeneous tabular data structure, right? So it's basically a collection of series, and that's something that we'll look at in a little bit. But really, what you can do is you can think of it like an interactive Excel file. You read in the data, you have all the data, and you have a bunch of ways that you can interact with that data, in ways that I find much more intuitive and much more powerful than working with Excel, which is a graphical user interface, but this is a programmatic interface, and it really lets you do a lot more. So again, it's a big thing, and we're going to take a look at it right now. So we've got our data frame here. We've stored that in a variable, and we can then start to sort of take a look inside of this data frame, right? So unemployment DF, and we're going to use the info method, and we're going to get some information from this data frame. You see that it gives us how many entries there are. You see that it gives us how many columns there are. So the columns are country, which we saw. The columns are unemployment rate, which we saw. And then we also have the types of the values in it. Remember when we were working with NumPy, we saw different arrays had different types, and that's what's going on here. And so we've also got how much memory is being used and that sort of thing. So this is sort of just a top level overview of what's included in your data frame. We can also use describe. And I really like this one because it gives us just a quick overview of the numeric values in it, right? So we have the count, we have the average, we have the standard deviation, the minimum, the maximum, that sort of thing. This is a great, just sort of quick way to say, hey, what's going on here, right? We can also use, a number of other helpful functions to further get information. We might look at the head of the file, which, well, let me comment these out so it's not polluting our output space. The head will give us the top 5 values. We can also say the top 7. We can also do the same with tail. And again, this is just a way for us to kind of take a look at it and say, what's the top, what's the bottom, what we're sort of looking at. Notice how the output here is somewhat interactive. Feel free to play with this. We see that we're seeing the column headers, we're seeing the values in each row connected to the column headers, and we're also seeing the index of the values, which we're going to talk about in more detail. But you should be seeing a sort of interactive situation in your output, which is nice. We can access the data in a lot of different ways, which is something that we're going to be talking about. But if we look at, for example, unemployment, we can use bracket notation, much like you might expect in a like a Python object, where you're basically just saying, get me the value here at country, and it's going to give you an array of all the values that match that that are in that column, right? So we can also say unimp. So if we look at our unimp rate, we'll also get those values here. We can do the same thing using dot notation. But I do find that this can be a little bit troublesome. Like if you do have columns with spaces in it, let's say someone actually spells it out, you're not able to add that space, of course, with dot notation. So sometimes it's easier just to keep things using bracket notation, but of course that's going to be up to you and to the team that you're working on. So let's try and access this at an index, and notice how we're getting an error, right? So there's no real idea of like a list type here. It doesn't work like a list. You can't access it by this particular index. You can get it by its index, as I mentioned before, 0, 1, 2, 3, 4, but that's going to be done in a specific way that we'll cover. So I mentioned before that data frames are basically collections of series. So if a data frame is a 2-dimensional object, a series is a 1-dimensional object, right? So it's sort of the difference between a matrix, which is a data frame, and a vector, which is a series. So again, let's just take a look at the source reference here. So a 1-dimensional ND array with axis labels, right? So we'll take a look at getting a series. So if we do unemployment df equals, at country, we'll see that countries is a series, right? So we're just accessing the column country off of the unemployment data frame, and then we're getting the type of that, which is going to be a series, right? But notice how series is a different data structure, right? So if we did want to do something like do info or describe, it's not going to have those methods, right? So if a data frame is composed of series, a series is not going to necessarily have all the same methods as the parent structure. Cool. So remember when we first started, we were talking about vectorized operations in NumPy. Again, Pandas is built on top of NumPy. So we get a lot of those vectorized operations for free, which is great. So if we wanted to do something like, so we're seeing the countries here, right? If we wanted to add a string to that, it would be very easy, right? And we would still see those strings and it would be added all the way. And remember, this isn't something where we're iterating over each of them in the same way that we're iterating over a list in Python. It's a data structure that's very efficient, and it's just actually adding those in a vectorized way so that it's a lot quicker. But we can't do this, right? So we see that there's a conflict between the values that are in the countries series and the numeric data type, right? So you can't just add a number to a string. It doesn't really make sense. Of course, we could do this, but that starts to become nonsensical, right? So let's look at, I want to make sure I'm getting this, this variable name right. So let's look at selecting unemployment rates as a series, right? So we have that, and we see what the unemployment rates are. Right, and we look at what this type is, and we see that it's a series. So we're looking at that, and we want to be able to sort these values. Right now, they're not sorted. If you take a look at that, they're a range of values. So what we want to do is we want to use a convenient method where we say unemployment df.sort values, and we're going to sort by the unemployment rate, right? So we're taking our data frame and we're sorting the values, and we need to then catch that value and store it in a variable. And let's inspect it. All right, so we see that it is now sorted. Greece at the top with the highest unemployment, Iceland at the bottom, or however you want to call it. But if we wanted to switch this up, we could use a flag argument where we say ascending equals true, which is by default, or ascending equals false, and switch it up. All right, so again, if we wanted the top, the first 5, we could do that. If we wanted the bottom, we could do that. Right. We're going to put this back to ascending is true, and we'll see that head is now our top 5, right? So we're going to do a quick exercise. It might take you about 5 minutes to complete, but the goal is for us to get the average unemployment of the 7 countries with the highest unemployment in Europe. All right, so we want to select the 7 countries with the highest unemployment and get the average of all those values. So take about 5 minutes right now, 4 or 5 minutes, and work through that. And then we'll jump in and do it together. And if anyone has any questions, if your notebook isn't running or there's some other issue with you doing that, feel free to reach out.
Hey, Andy, for some reason, when I'm typing like in the notebook, it's not actually like processing what I wrote.
Yeah, so I want to make sure that it's not, there's a couple things that might be happening. So let's start with the first one. What I'm doing, which maybe I should have mentioned when I'm doing this, is I'm actually clicking Shift Enter, and that'll run the cell. Or you can click this button up here.
Oh, okay.
And then you'll see the output there.
Okay, yes, it's working now. Thank you.
Okay, great. Yeah, sorry I wasn't more clear about that. Just another minute or two. All right, let's start wrapping up. If you didn't finish it, no problem. We'll walk through this together. So yeah, so of course there's going to be hundreds of ways to do this. I'll walk through how I might have done it. But real quick, does anyone think they have the solution? Not just yet. Cool. So yeah, we'll walk through it here. This is how I did it. I went through and I got the unemployment sorted as descending, right? And I try to be, as specific with my naming as I can be, even if it gets long. But I took the unemployment data frame and I sorted those values by unemployment rate. Rate, and I got the ascending to be false. right? So I wanted the top values at the top. And then I wanted to also then get the highest unemployment. And so I took this set of values and I got the top of those. And remember, it was the 7 countries, so I got the top 7. All right, so let's just see then from there, I'm going to get the highest unemployment average or mean, and I'm going to use this series there, and I'm going to get the unemployment rate. And then because I'm getting that series here, I can just attach the mean value there. Does that make sense? Right, so we're sorting the values by unemployment rate, and we want the top values at the top, right? So Greece is going to be at the top. And then we're getting just the top 7 of those, and we're going to get the highest unemployment from there, and that's going to be a data frame. And then from there, we're saying of the highest unemployment, let's only get the unemployment rate and then get the mean of that series. All right. Cool. So just a couple kind of extra things that we can look at. We might look at unemployment rates here. We might get the, we might get the minimum, we might get the max, we might get the sum. And these are just convenience functions that say the lowest one there, or the highest one there, or the sum of all the values there. A couple other helpful ones are unique and n-unique. So for unique, it'll show us all of the unique values in the unemployment rates. Or we might also say n unique, which is going to be the number of unique values. That can be really helpful. So there's 29 unique values, and we know that there are 32 entries, which means that there are at least 3 duplicates there, right? We can also then just inspect that and say, of the unemployment rates, which ones are duplicated. So we're using the duplicated method, and if we look at that, we can see, again, we're getting a Boolean array here, and we know that entries 22, 23, and 24 are duplicates, right? So there's a couple more there. Just you might find those useful as you go through. So let's keep pushing ahead. We're going to be working with a lot of different file types, as I mentioned before. And so I'm going to pull in, on our way to sort of combining data and working with different file types, I'm going to pull in another CSV, and feel free to do this along with me. So if I were to say the GDP data frame, we're going to read in our CSV, and we're going to do that with the file path, right? So here's just an easy way to store that file path in a variable, and we're going to read that through. Okay, so let's inspect that again. We're going to get the GDP data frame, where we're going to get our info, and we're going to see it has the same country column, but it has GDP values in it. So again, let's just take a look at what that is specifically. You might do this as you go, open it up in Excel or whatever, and we see that it's very similar, right? We have all the same countries, we have GDP values, right? Gross domestic product. And what we want to do is we want to merge those data frames. We want to say, how can we see the data together so that we can, do calculations that have those columns be related to each other. So we're going to merge that data. So we're going to start a new data frame, and we're going to call it Europe data, right? I could probably come up with a better name than that, but we're going to use a method called merge. And this is, I think, really where the power of Pandas starts to become clear. Of course, there's many ways to do this in Excel as well, but it starts to get a little bit complicated, especially as you have multiple files that you're working with and multiple drafts and lots of different things. So I really like using Pandas for merging Excel spreadsheets, and we start to see that this data is now collected together. Right, so it started out as country and unemployment rate and country and GDP, and now we have a single file with this data. So if we look at the head of it, we can see that. So let's keep including data. Let's keep merging this together. I've got another set of data, and this has miscellaneous data. Again, I probably could have done a better job naming that. Well, let's just look at that particular file. I'm going to open that up here. It's opening up my Excel. And you see that it has the same deal where it's the country, you have the total population, and you have the percent young adult population, right? So we want to be adding this data in. So how do we do that? We're going to do popdf. That's going to be our population data frame. And we're going to say pd.readExcel. And so before we were reading in CSV files, and now we're actually going to be reading in Excel files. So we want our miss file path. And notice how we're basically saying we're going into the data directory and then we're grabbing the miscellaneous data file, and that has an extension of XLSX. All right, so we're just going to see what that does for us. But notice something, that we didn't get the values that we thought we were going to get, right? So we're looking at the population here, but what we got, if you take a look down here, was a different sheet, right? So with dynamic, Excel files and a number of other file types, you can have different sheets on your file, right? And so we got the average hours worked, which means basically what this did is it said there are multiple sheets here, and by default, I'm going to select the first one. And so that's not ideal. We wanted the population. So instead, what we're going to do is we're going to say the sheet name will be population. So we're going to grab by the name here, and we're going to get that now. So now we're getting the population, right? Or we could get the income, right? But if we do get the population, notice there's some issues here, right? So again, if we take a look at our source data, we're seeing that whoever we're working with ended up putting a title up here, and it's not really able to infer what the column names ought to be, and instead is giving us some random weird data where there's not a number of values, they're empty, that sort of thing. So we're going to add another argument here for skip rows, and we're going to skip 3 rows. So 1, 2, 3. We want to skip those. We don't want to include those. And now we see that it's proper. We've got our column headers, we've got our rows, and it's looking pretty good. All right, so now let's take a look at how did I move forward on this? Yeah, so we have country, we have total population, we have percent young adult population, and we don't need that. So we're just going to get rid of it, and we're going to say total population. Actually, let me do this in a new cell. Yeah, so we're going to jump down here a little bit. So total pop is equal to popdf. And again, we're just going to select the values that we want, and that's going to be total population, right? So we have total population as the column header, and we're going to get that. So let's see what total population looks like. Great. Yeah, it's just the values, so it should be working fine. So why don't we take that and we will add that into our Europe data frame. So pd.merge your data total population, right? So what we're doing is we're saying we want to merge our existing your data column, data frame with our total population data. And you see we're going to get an error, right? And why do we get this error? The total population series that we got is just that. It's a series, but there's nothing for Pandas to actually know how to merge the two together, right? So these are just essentially Pandas is saying this is random data. I don't know what to do with this. And so it brings up a really important point that you need something for Pandas to know to merge on. And in this case, we need to include the countries so that Pandas knows to merge on the countries. So something similar about the things that you're merging so that they can be together. So let's get that. We're going to get total population with countries, and we're going to get the population data frame. And we're going to do something a little bit more complex where we're going to select two columns. Right, so we're passing in an array, and we're saying we want the total population and we want the country. Right, so when you want two values or two columns, you can add in an array rather than just saying country. We want to add both of those. Right, so now we have total pop with countries. Now we have country and total population. And so we are going to merge Europe data with total pop with countries. And we're also going to sort it. We're going to sort it by country. And then we're just going to take a look at what we've got. Right, so we now have the country, we have the unemployment rate, we have the GDP, and we have the total population in a single data frame. And it's sorted alphabetically by the country. And we did that using sort values, and we passed in our argument as country, which is what we wanted Pandas to sort by. But notice here that there's a bit of an issue with our indexes, right? So it goes 0, 1, 2, 13, 4, right? So these were the initial values that Pandas gave as the index for this particular data frame, or the entries in the data frame. But now they're a little bit off, right? Not going to necessarily hurt anything, but it might make it a little bit harder to read, and it might mess up some of your work later. So let's take a look at what an index actually is. An index of a data frame is an immutable sequence used for indexing and alignment. This is basically, the key labels that you might use for each individual row. So in this particular case, our data is indexed by integer values, right? So we can take a look at our data frame, which is your data, and then we're going to get this attribute, which is index, and we're just going to see what it is. And we see that it's an index, and it has these values. Right, so it's just integers, right? You can also index by strings. You can index by strings with spaces. You can index by a whole bunch of things in Pandas, right? But notice if we did want to say, you know what, in order to change our index, let's say we want to change our, 11th index, right? So at index 10, we want to change it to apple pie. It's gonna yell at us, right? Because as we saw in the documentation, indexes are immutable. Because really what this is it's Pandas' way of organizing the data. And so they don't want users to be able to say, I'm going to change this one value, because then it won't necessarily know how it changed, how its change relates to the other values at the other indexes and things like that. So it doesn't mean we can't change them at all, but it just means that we don't want to be able to access them to change them like this. So what we're going to do is we're actually going to change it up so that they're indexed by country, which makes sense, right? So right now we have country as a column name, which is fine. But you might also think of this as an Excel spreadsheet or a data frame or whatever that has 3 columns, and each row is just named by the country. And that's what we're going to do right now. So what we're going to do is we're going to say our your data country index is equal to your data sorted. We're going to use a method called set index. And the set index is basically a way for us to reset what the index is, and we're going to use existing data. We could also pass in our own values here, but for now, we're just going to tell, hey, Pandas, you know that this country data exists already, so please just use that. So let's take a look at what it looks like now. And we see that it's changed a little bit, right? So again, we have our 3 columns, but now notice how country is just lower in the margin, which just indicates this is the name of the index. So it's indexed by Austria, it's indexed by Belgium, right? So as a somewhat shallow dive into indexes, you're going to be working with them a lot. We're going to talk about multiple hierarchical indexing, which is really helpful for complex data science tasks. But we're going to put that aside for right now. Are there any questions about indexes at the moment? Cool. So right now we're going to talk about exporting data. We've got our data frame, which has these 3 values and is indexed by country. What we're going to do is we're going to write that out to a file. And this is always something that gets me excited. I think that, to even 10 years ago, even 5 years ago, a lot of this reading and writing functionality was a lot harder in a variety of different fields. And this just makes it very easy. So what we're going to do is we're going to say, let's see, we're going to get our file path. And we're going to use a convenience function that I wrote called get file path. And we're going to pass in 2 arguments, the file name and the extension. And notice how it's just returning a file name or a file path that has a path to our data folder, the out folder within the data folder, the file name, and the extension. So the first thing that we're going to write is your data sorted, and we're just going to write a simple CSV file. And then we take your data sorted .to CSV, and we're just going to pass in the file path, right? So we've got, let's just see what our file path is. Whoops. We're just going to see what our file path is, right? So this is the value that we're actually going to be passing into our to CSV method. And what that's going to do is it's going to take all the data that's in your data sorted, it's going to write it to a CSV, and it's going to do so at this file path, right? So if you run that and you open up your out folder, you'll see that you now have a CSV file. You might already have these files here, depending on if you've run this before or if they were part of the cache initially, but you can see that when you do run it, that you will get a last modified update of seconds ago. So now we have it, and this is pretty cool, right? So we now have a CSV file. So what we're going to do is take just a couple minutes, and you can walk through and do a quick exercise of doing this to Excel, doing this to JSON, doing this to HTML. And I've got this get file path helper function. The hint is that really what we're doing is we're just changing extension. And then Pandas itself actually knows to write to different file types. So take just 1 or 2 minutes now and write out a few of these, and then we'll do it together. We'll take a look at how to do that now. Again, there's multiple ways to do this, but how I'm doing it is, oh, shoot. So I'm sorry. I gave a bit of misinformation here. I said that the only thing that we needed to change was the file extension, and we do need to change the method as well. So if anyone got tripped up on that, I'm sorry. But basically how we're going to do that is we used toCSV before, and now we're going to use for Excel, we're going to say toXL. And I'm going to do this in one line, but you can do it however you want. Again, we're passing into values, 2 arguments. Again, this is just its own function. Get file path, your data sorted, and then add in the extension. And I'm just passing in the whole function into the toXL method. And we're going to write that, and then you'll see again that this is updated, and we now have an Excel spreadsheet that Binder won't be able to open, but right. And then I can just copy that down here to JSON, and then change the file extension. Let me write out to JSON. And let's take a look at JSON, actually. This is really interesting. For anyone who has worked, with web applications or, downloading data off the internet, JSON is a huge part of that ecosystem. It stands for JavaScript Object Notation. And it basically is, it looks like a JavaScript object, and it gives us all of this data organized in that particular way. So you might see this, if you're on the internet and you're downloading data or any number of things. But it's really convenient to be able to just write directly to that, so you can feed it to different data sources. All right, and then let's do HTML. Again, I'm going to copy that here and write to HTML, and then change the file extension. And there you go. And this one's really exciting to me. I'm a web developer here at Harvard. Being able to just write, you'll notice that this is a working web page. So now we have what appears like a data frame, but it's completely structured. And this is something that you can post online, and people can actually visit this page, right? If you post it properly, and that's really exciting. It's very easy to make it an HTML table using Pandas. Are there any questions about this? Cool. All right, so that is a brief introduction to writing to files with Pandas. So what we're going to do now is we're going to be doing some more work with our unemployment data, but just to make sure that we're all on the same page, what I've done is I've put together a file with all of the data in it that we're going to read in, just so it's formatted the same way and all of that. So what we're going to do is we're going to say your data final, and we're going to read a CSV. And we're going to put in a file path. I should have included this, sorry. But we're going to go into the complete folder, and we're going to use your data final.csv. And we're going to add one more argument here, and we're going to tell Pandas that we want our index column, so the column that we want to use as an index, to be 0. And that just says of all of the columns in the data, we want the first one to be our index column, right? So let's just take a look at what the result is. Right, and we could do, something like that where the country is what's indexed, but we're going to use numbers for now. All right, so I added in a median income here, but again, this is just a formatted version so that we're all on the same page. Again, we can sort of just inspect this data if we want, and we can say, describe this data for me. Okay, so we're seeing, the values there. We can get the top level info of that data. And then, if we wanted to, we could get the average of all of the columns, which is helpful, right? And again, this is basically the same data. I made it a little bit more precise for our purposes. So you're going to see it in, scientific notation here. Because the floating point numbers are a lot larger. Cool. So one of the big things that we talked about with NumPy was Boolean indexing. And I think I mentioned time travel for a quick second to 2 sessions ago. I mentioned that it would be very important with Pandas. And it is. A big part of what we're doing here is we're saying, I basically want to get a Boolean series out of this particular data frame that I can then use essentially as a querying tool for that particular data frame. And let me walk through exactly what I mean by that. If we take a look at, let's just take a look at our country column, right? And we see all of these countries here, right? So we have 0 to 31 and all the different country names. But if we were to say, for example, that we want your data final country is equal to Austria, we would actually get a Boolean series out of that. So let me show you what I mean. We would then get the first value is true because that is the country that is equal to Austria, and the rest are false. Right. So that we can then use this series to query the data frame so that if we wanted to then say, okay, your data final, we're going to get the values that correspond to this Boolean array, we're only going to get a single row that matches Austria. Right, so it's a little bit funky, but basically we're saying, give me all the countries that match Austria, and I'm going to store that in a value, and then I'm going to use that value to query against the overall data frame, and I'm going to get this value. Let's try it again. So we're going to get Greece now. So if we wanted the Greece Boolean, we would go your data final dot country. We can also do this with bracket notation. Is equal to Greece, and then we're going to say your data final, and again we're going to access it with this Greece Boolean series, and we're going to get Greece. So this is what the Greece Boolean looks like. So all of the rows are false except for the one that is true for Greece, and then we're going to use that to access just the Greece row or entry. This is the very basic version of it, but it becomes more complex. For example, we can get like partial matches to these queries. So if we were to say like L names is equal to your data final, again, we're getting all of the values in the country column. And then we're going to use an attribute called the string attribute. And that is .str, and basically says, give it to me as a string. So each of the values should be a string. And then we're going to call the contains method on that series of strings. And it should say contains L. So let's just take a look at what L names looks like. Again, we're seeing all of the entries in the country column that have L in the name. And so what do we do with that? We can say your data final L names, and we get all the values, all the rows that have L in the name. Right? But notice there's one missing, and I left this in here so we can take a look at it. There's one missing, Luxembourg. Right? So why is Luxembourg missing? It has an L. Right? And the reason is that it has a capital L. And this contains method is actually case sensitive. And so we're going to do the exact same thing that we're doing here. We're taking the country values, we're converting them to strings, and then we're using the contains method, but we're saying that we don't want it to be case sensitive. So case is going to be false. We're storing that in a different variable and then accessing it. And notice now that we have Luxembourg. Are there any questions about that? Cool. So we've been working with a single query, right? It might contain L or N or be equal to the country of Austria or whatever. But what we're going to do is we're going to start doing multiple queries, and we're basically going to start defining different conditions that will check against the data frame. So in this case, we're going to look for low unemployment. I'm not an economist, maybe this is medium unemployment, but I'm just going to call it low unemployment as anything less than 7. Maybe someone can correct me on that. Maybe that's a different word. But we're basically going to access the unemployment rates for our data frame. And we're going to say that those unemployment rates are less than 7. So now we basically have a query. So low unemployment rate, again, is a Boolean mask, they call it, or a series, but it really functions as a query, right? And so we're also going to say your data final, we're going to say L names insensitive and low unemployment. Right, so we're now taking this and we're combining these two. So all of the L names that have low unemployment. And I'm doing this incorrectly because here we'll see that there's an error. And the reason that I wanted to point that out is that you might sort of think of the standard Python operators, and or not, that sort of thing, as acceptable here, but they're not. We have to do this in a different way. And I'll show you how. We're actually going to use the ampersand. So this is specific to pandas. You have to use an ampersand here. And then you can actually get the query that's combined. And you can chain these, right? So you can do, another query and that sort of thing. And in this case, it'll be all of the L names that's insensitive and all of the low unemployment. So which countries have low unemployment and an L in their names? Right, so this is the set theory and, right? Or intersection, sorry. In set theory, it's intersection. And then we can also do union. And that is the pipe. Might not be a key that you're used to using, but that's the pipe key. right? So that is all of the countries that either have an L in the name or low unemployment, right? And in this case, it's all of them. And then we also have the complement, which is your data final and low. We're just going to get the countries that don't, that don't have low unemployment, and we're going to use the tilde. In other words, these are all the countries that have high unemployment. Notice Sweden has 7 because we didn't use the equals to operator comparison, sorry. So even if it has 7, we're considering it as low unemployment. Again, maybe not the correct way to think about it from an economics perspective. All right, so we're going to do a quick, we've got another 10 minutes or so. We're going to do another exercise. And what we want to do is we want to find the countries that have an unemployment rate greater than 9% and a GDP less than 280,000. All right, so we went through all that. You should have all the tools that you need. We'll take just a few minutes here and then we'll go over it together. Looks like I lost my binder, but that's all right. I've got a local version as well. Why don't we walk through that? And I'm noticing that my my answer in the complete one is not correct, but that's okay. I got the questions flipped up, so we're going to do it together. Essentially, what I ended up doing was what countries have an unemployment rate greater than 9%. What I ended up doing is as I said, the unemployment rate greater than 9, and also just say 9, is equal to the your data final, and we access the unemployment rate greater than 9. And we also got the GDP less than 28, and the year data final dot GDP is greater than 28. Did I say 280,000? Yeah, we'll say 280. Yeah. And again, you can use an underscore here, and Python treats it the same. I just find it a little bit easier to read. And so what are we going to get? We're going to get final equals your data final, and we're going to say unimp GT9 and GDP less than 280. And these are our values. So these are the countries that have a GDP greater than 280,000, but also an unemployment rate that's greater than 9. So I want to do one more, and I want to figure out which countries have a median income greater than 10,000 and less than 200,000. I'm sorry, 20,000. Right, and so this is a way for us to start to combine these different values, these different queries. So notice here how I put in your data final median income greater than 10,000, but then I was able to just combine it here using the ampersand, and then do the same for less than 20,000. So here instead we have a single query that is a combination of two different queries, and I find that that's just a little bit easier to read, putting that into our your data final data frame. So now we basically have all the countries that have between 10,000 and 20,000 exclusive. An alternative for us to do is we could do an income query alternative and say that the median income is between, so this is another method on the series that we select, and it would be between 10,000 and 20,000, and we can just say that it is inclusive. Notice how we get the same countries. Cool. So we're coming up on time. I want to leave the last few minutes for anyone that has any questions. But before we do that, just to give you a preview of next week, we're going to be talking a lot about selection. This becomes really helpful in getting the data out of the system, out of a data frame. And we're going to be talking a lot about how we can use selection in conjunction with queries. And we're also going to be talking about hierarchical indexing and other complex ways that we can organize our data to make our data workflows work a little bit better. Great. So that's all the content that we're going to cover today. Did anyone have any questions or thoughts?
Hey, Andy, I had a quick question for the inclusive part that you added for the alternative. When you say true, does that mean you're including the 10,000 and 20,000 if those happen to be values?
That's a good question. Yeah, that's a good question. You would be including those values. Yeah. So, okay. Yeah. So if we said inclusive false, if a value was 10,000 or 20,000, it would not be included in the results.
Gotcha. Okay. Thank you.
Yep. And then we can do the same here to make this query inclusive. We would do this.
I have a question about the dot versus bracket notation. So for the dot notation, you can use that to like call, for example, a certain column of the data frame and then also like call a function on that column, like mean, for example. Can you like mix together the dot and bracket notations for that kind of thing? Or like if you do you have to use all dot? Because like for the functions, I think you can only use dot, right? You can't like put them in brackets.
Yeah, that's a really good point. You can only use bracket notation for accessing data, and you can only use dot notation for calling methods. So Generally speaking, I tend to prefer using bracket notation for accessing stuff. But again, here, you can use, you can access median income as, through the dot notation. I think you bring up a good point that, in the event that we called one of our columns, mean, it would start to become really complicated, right? If our column name was mean, this also has a mean method on it. Which I think is another reason why you might want to just always use bracket notation. Does that answer your question?
Yeah. So now, yeah. So now that you've changed it to bracket notation, you can still apply mean to that by just putting dot mean after brackets, right?
Correct. Yeah. And one of the hardest parts for me working with some of these complex Python libraries is that the term or the method mean exists in a lot of different places. So mean works here, and it also works here. And it works on series and a number of other things, right? So you sometimes have to kind of go drilling through the documentation to know exactly what's going to be accessible at any one time. But yes, mean would work in both places.
Thank you.
Yep. Cool. Yeah, any other questions? Great. Well, thanks everyone for coming. We got one more day next week, same time, same place. We'll send out a reminder email, and we're going to wrap up working with Pandas. It'll be our last session, and we're also going to work in some more matplotlib, and maybe to take a look at Seaborn as well. So hope to see you all there.
Cool. Thanks, Andy.
Yeah, absolutely. See you later.
Thank you.
I actually have another question related
Sure.
to dot and bracket notation.
Yeah.
So I think you mentioned that you generally prefer to use bracket notation for like calling a certain column or like finding stuff within the data frame. Does it make sense to kind of, as a general strategy, say that like you're going to always use bracket notation for that, so that when you're reading your code, it's like quicker or like easier to figure out what you're doing? Because like, I mean, a lot of the stuff that is hard for me about this is like visualizing the data that I'm working with at the same time as trying to like code it. Like I always print like the head of the data so I can see my columns all the time because I just can't keep it in my head. But anyway, do you think it's like a good idea to like use that strategy of always using bracket notation, or is there any time when it doesn't work? Because some of the data that I've worked with in the past has had like multiple indexes, and it seems like either dot or bracket, sometimes you have to like choose. But I also could just be like writing the code badly.
No, that's a great question, and I am definitely an advocate for always using bracket notation. Of course, I'm not doing that here. I should be, but sometimes it's just a little bit faster than writing out the brackets. But generally speaking, if you always stick to bracket notation, you're going to be safer, and I think it's going to be a little bit more clear. It's going to be a little bit more legible.
Okay, cool.
When it comes to hierarchical index, and I'm glad you brought that up, we're going to talk about that next week, but you can always use bracket notations for hierarchical indexes.
Okay. Okay, cool. Thanks very much.
Cool. Yeah. Looking forward to seeing you next week.
Yep.
All right. Bye.
See you.